Alaikum assalam.
Father.
Iná yín máa rìkọ́dù ẹ̀ tán báyìí.
Mọ̀mí mẹ́ṣẹ́.
Ṣé fóònù náà lè rìkọ́dù ní fóònù lèmi ń lò?
Kájọ la yẹ kó lè record tán, ṣubú kájọ la wà mẹ́.
Dr. Kajola. Dr.
Ó kú Dr. Tẹ̀ fún lọ́lọ́nà. Ìwé lọ́lọ́nà ń lọ wáyé. Dr. Lukman, níbo lọ́lọ́nà wà?
Sọ̀rọ̀ lábẹ́ àná ẹni mẹ́sẹ̀jì.
Ok. Ẹ káàárọ̀ Dr. Gúnṣọlá.
Ẹ káàárọ̀ àfúnṣin.
Ọ̀pẹ.
Ẹ káàárọ̀
Ẹ
gbogbo
káàárọ̀ ni.
Ẹ káàárọ̀.
àkóṣin o. Ṣàkóso Hello, sir. I'm with you, sir.
No message. Ṣé bẹ́ẹ̀ rí screen yìí máa rẹ̀?
Yes.
Bá ń sọ fún pé mo wà lórí kọ́ọ̀dù.
Okay, so mo try láti wá ilé iṣẹ́ yìí ní ìtàṣe nínú Shiva Space ìròrí download lọ́pẹ́ school mo wà sí ìwọ̀n download rẹ̀. Eléyìí Springer eléyìí yẹ kí eléyìí easy láti download.
Ṣé wọ́n á send ẹ̀ sí mi kí wọ́n try ẹ̀ bá yóò download?
Tẹ́lẹ̀ download ọ̀fẹ́ yẹn rí.
Yeah, I should be.
DOI rẹ̀ ọ̀gbọ́n náà mo ṣe fẹ́ wá káàkiri nínú. Wọ́n lélẹ̀.
ẹ máa copy reference yẹn DOI.
I can check in there to download this. SC something of. Send this now. Only for problem for my application I won't be. So, any our fellow she correction to you. Our Dr. Abdulgafar. But I will not stand it was me. We will see. We're going to put our losses. So that we're going to work together now. Àjọ wa ṣe communication máa wà lára àjọ wà ní the same group. A máa fi èèyàn hanra wa. Ṣé rí download?
Kò tí ì ṣe mo ṣe tó fẹ́ wo platform ìbò mi nìṣẹ́. Mo fẹ́ login sí Scopus mi.
Tí o bá ti ṣe, a máa lọ lo but ilé ìwé kò ní help. But still, we máa try láti explain ẹnu wà ní jẹ́ ìtẹ̀lẹ́. So, èyí Sunday, mo lè fẹ́, okay, yẹ kí Grace Sunday sí. Grace wà school ti ẹ̀ wá. Tí gbogbo wa rí once mo ló máa dájú.
Bẹ́ẹ̀ ni sọ. Ẹ jẹ́ n try ní ẹ̀kan sí ọ̀dà ó ti fẹ́ di ẹ̀kan sí ní school wifi.
So, while we're waiting for that to be so just going on this before you download. When Grace will be able to download it from over to our school. So, this first lemma here is for all n, for all p in n and n in n. The following inequalities. I'm not sure about these inequalities. Hold on. Wow, it's already, I don't think we have Zm plus 1. This should be Zn. If at all, there's anything like that. It should be Uzn, not Uzn plus 1. I don't think there's an error here. So really correct. This one is right. Only that I will have to be sure. I will check it and now let's see the proof. So don't ignore me while I have it.
Yeah.
Yes.
À ń gbọ́ yín bọ̀ kí nìyẹn ò parí tó.
Báyìí kọ́. Tó bá yẹ pé orí fóònù lẹ tí ń wò ẹ fi sí landscape mode.
Assalamu alaikum, sir. Check.
Ẹ fi sí landscape. Tó bá yẹ pé orí fóònù lẹ tí ń wò. Otherwise,
Alright,
clear.
ó ti ṣe báyìí.
Okay.
Ẹ wo, àyẹ̀bọ̀ àwọn ilé òní sọ pé àwa, àwọn ilé òní sọ pé àwa.
Wọ́n ti bá àwọn politician kan ní máa kọjá.
Kì í sáwọn olóṣèlú àwọn mẹ́jẹ movement for a
Okay, so we start with this one here. But alákọ̀ọ́kọ́ náà, nǹkan tẹ type sí ní tábẹ̀rẹ̀ kò tiẹ̀ sí there's nothing about what's it called? I want to meet the person.
No, development
Tí o gbìyànjú lè.
gbogbo ọ̀dọ́.
Ọlọ́nà ẹ bá mute ara yín.
I've done that. So, first, fi kí lórúkọ ẹ̀ sí. First part of the result, which is boundedness, kò sí nǹkan tó jọ bẹ́ẹ̀ ń bí.
Yeah.
So now, let's work with this one that we're saying. Using the Cauchy-Squarz inequality and lemma 2.1, we have rather, I don't know if you're seeing what I'm saying. It should be lemma 2.1 first, then Cauchy-Squarz. Lemma 2.1 le fún wa lélẹ̀. Cauchy-Squarz tẹ̀lé mi báyìí. Maybe bóyá kí ni ẹ̀yin lè fi to alphabet C and L. But bó ṣe wá lèmi rò pé like this was lemma 2.1 and here is Cauchy-Squarz because Cauchy-Squarz will lead to step here. Okay, so
Alright, ohun tó yẹ ká kọ ní ìsìn pé lemma 2.1 then
and here the definition of M3 was not given. We don't know what M3 is. Just say this one is less than this guy squared plus 3M3 alpha n over psi n of verify n phi n.
Àwọn previous estimate láti ṣe tẹ́lẹ̀, okay, àwọn ò kàn bẹ̀rẹ̀ láti bẹ̀.
Yeah, so this definition has to be given. Then similarly applying the same steps for f wn minus p. No, but only man need to buy. Who's calling me? I just for me 1 minute, I just can be calling.
I think it was a typo. Yeah, how much typo in? Just to present something.
Now, since it's the same step, so similarly apply the same steps for
Hello, doctor. Hello, doctor.
Similarly,
Hello, doctor.
we,
Hello.
yes, sir.
Something is I observed an error somewhere.
Bẹ́ẹ̀ni sà,
Okay.
níbi
Before
line
Similarly, yes.
The 3M3 yẹn, that pie head is missing.
Pápá ẹ̀ ní wà ń bẹ̀.
That pie head is missing there.
Ibùlé ẹ̀kọ́ wà.
3M3,
Ó yẹ
the
kó wà
3M3
ní
yẹn.
ilé àpá
In the
M3.
3M3, there should be vapor hand before alpha end or vapor end. So that when it multiplies out, it will remain an alpha end there.
bẹ́ẹ̀ni
In the
bẹ́ẹ̀ni sà.
3M3, vapor hand is missing. Vapor hand should be there.
Ó yẹ kó wà ní ẹgbẹ́ báyìí náà, àbí?
I think it's missing there.
Typo error ni ẹ má bínú pé ká lè rí nǹkan.
Okay.
Okay, well,
The same
if
thing
they have
happens
said there's
downstairs.
an error
Ó tún ṣẹlẹ̀ nísàlẹ̀ náà o. Ó tún
Number
ṣẹlẹ̀
of
bí
error
Ẹ
wà
níbi
ńbẹ̀.
line 3 yẹn ní.
Ibi M4.
Number
the same
Bàtà
thing
of
happens.
factorize
error wà ńbẹ̀, then please go ahead and make the correction. That's under correction. Àti pé correction náà la fẹ́ ṣe.
alright
So,
sir.
which is good. Tá a rí i pé èmi ò tí ì mọ ibi tẹ́rọ̀ táwọn sọ yẹn wà tèmi. Kò yé mi.
Ibi tí kúsọ̀ wà ní bẹ́ẹ̀ gbé kúsọ̀ sí.
Line
Ẹ wà
3
ní
yẹn
Mú
ní.
wọn, ẹ sọ pé ó yẹ kí irú eléyìí kó wà lókè báyìí, àbí?
Yes,
No,
yes.
3M3, vapor hand, then alpha end over vapor end. So that when it multiplies out, it will remain alpha end. Don't 250.
Ó yé mi. Mo understand nǹkan tẹ́ ń try láti sọ, but mi ò mọ̀ bóyá ó ṣó correct báyìí ṣá. But nǹkan tí a fi máa mọ̀, tá a fi máa mọ̀ bóyá ó correct, ṣé mo kọ́ tá a fi máa mọ̀ bóyá ó correct ni pé kí ni definition M3? That's it. Intention yẹn lè correct ó dẹ̀ lè má correct. Tó yẹ kó gbà tán define M3 wọn, intention yẹn ti wà bẹ́ẹ̀ nǹkan.
Okay, that's an idea.
Okay.
Ṣé understand nǹkan tẹ́mi sọ wá yẹn?
But tó bá jẹ́ estimate là ń lò bọ̀ tẹ́lẹ̀ bó ṣe wà nìyẹn.
Tó bá jẹ́ wípé M3 wọn, for instance, is just this guy, the maximum of this one and this one. So ẹ máa sọ pé okay. But tó bá ti lọ fi vapor and tension ìṣe, tó bá ti fi multiply that definition of M3, then nǹkan tẹ́yìn sọ máa wrong nìyẹn.
All right.
That's why I said, okay, what is the definition of M3? Because we have to know what M3 is. So that was my M3, I was like, okay, you got this on wrong, wrong. There is something missing. Does it get to right?
Okay.
M3, yeah, push you. Then for this, if they said similarly applying the same steps for WM minus P, you have basically repeated everything here. You need the case of similarly one.
Yes.
So I guess let's repeat. So similarly, from definition of WN, we have and this is wrong. This is not supposed to be xn plus 1. This is supposed to be UN, if I'm not mistaken. This is supposed to be UN. Again. Because this is not definition of xn plus 1. Ele is a definition xn plus 1. Definition UN ele. At WN jojora. Xn plus 1 TTL. 1 minus alpha pi this pi n. Phi n rather. This phi n multiplied by f of tn, if I'm not mistaken, plus 1 minus phi n something. Only definition xn plus 1. So this is supposed to be UN. This has to be the M3 here. We need to know what M3 is. What is M3? So, and here I said similarly, it is just similarly from the definition of WN. From the definition of WN, we have, so I can solve WN minus P squared is less than or equal to, so just WN minus P squared, just this step, could need delay. Because it's the same thing that we are repeating, just same step. So to just go straight forward, this guy is less than or equal to this. So similarly from the definition of WN, we have this guy is less than or equal to this guy, where M4 is whatever M4 is, because we have to define M4. So clear. The KTXN plus 1, this is its own definition now. Okay. Now let's look at that definition and the way that works it. So if you look at that, yes, which is equal to that, yes, which is less than or equal to the first one there. I don't know how you got about that. 1 minus See, what I'm getting is at the same time, you have not established a connection between this guy and this guy. Yeah, I will think 50m minus 50 plus 2 are less than 11. There's nothing that points at that. You know, but one do we won't be able to say okay, but actually, oh, correct. Because like here, there's no problem with this. Here, we know what has transpired here. But Ele, how did you arrive at this? This is Tm minus p square. There is nothing Tm minus p square here. So Tm minus p square, because there's a shame by already. Then how did you make that substitution? So those are the things that you have to. That's why I said the first part, which is the boundedness, which will have included this kind of expansion, is not inclusive here. So you have to put that in your okay. Now, because we will not be able to see that this thing that you've done unless allocing effort and me that okay, this is true. But now we have to stick to this because this is where we're making our correction. So that first part, which is the boundedness, has to be tight as well. We must have that. So like there should be something before here. We don't just go directly to TN. So I think it was from TN has to go to ZN or go to WN first, but I'm not too sure now. And again, another thing is the algorithm is missing. So if the algorithm is not there, that's where we were going to see all those things. And just like I said from the beginning, Elaine saying this will be an error because there's no ZN plus 1. So
ZN.
So here I think that settles that for this one alone. But in the lemma, the hypothesis points us at two things. This first one here and this second one here. But this theorem, the result has concluded just proving only one part. That's the inequality odds. But you say it's two inequalities. This is just one. Maybe did I make a mistake of presenting by myself? Shouldn't have said the person doing the seminar to present. Ta ló lórí kó wá kọrin fún
We are
aláàrẹ wa.
making correction. But we correction là ń ṣe ni.
Correction and
Correction là ń ṣe. Correction là ń ṣe, that's true. But still, ṣe mọ̀ pé ẹni tí ó bá borin olórin jẹ́ ló sọ pé mi ò ní kọ́ bó ṣe. Yorùbá ti pa mí, mi ò mọ Yorùbá yẹn. Ẹ bá mi sọ Dr. Aluko.
Mi tí mo tẹ fẹ́ sọ mi lè tinú yín mọ́rọ̀.
Ẹni tí ò bá ní borin jẹ́ ni ó kọ́ bí olórin ò ṣe kọ́. Ó yá ẹ sọ ẹ mọ̀. Dr. Ogunṣọlá, àgbọ̀nìtàn lórílẹ̀.
Bẹ́ẹ̀ mi ṣe mọ̀ sí ni pé ẹni tí ó borí olórin jẹ́ ni ó kọ bó ṣe wù ú. Ní àwọn borí olórin jẹ́ sìn bó ṣe wù ló lè kọ kò ní kọ́ bó lórin ṣe kọ́.
Báyẹn ni. So ẹni tó lórin, we are can present orin wọn. But okay, we're asking them questions now. Like here, so the conclusion of this lemma, there are two things that you hope to achieve. This is 1.1, and this is 1.2. But at the end of the proof is just one, which is this. Dr. Gafar. Ṣé Dr. Gafar wà mẹ́ta?
Ó dà pé wọ́n ti mú Sara.
Our teacher, ẹ̀jẹ̀ á move forward kọ́ máa lọ pẹ́ nípa tí máa wo ti Dr. Ogunṣọlá yẹn.
No, nígbà tí mo tọ̀dọ̀ mi, kí ló tún kù mẹ́?
No, a fẹ́ ṣe àgbẹ̀ wọn fẹ́ pín wa lónìí.
Kò sí nǹkan tẹ́ fẹ́ wò mí tọ̀dọ̀ mi àbí dókítà.
Ẹja máa wo eléyìí lọ́nà. Tá a ti parí eléyìí. Tó bá yẹ ká wò wá sí padà wò. But a fẹ́ pínra wa lénìí náà ní ṣá. A fẹ́ pínra wa lénìí. So, we were 6 before. Ta ló ti kúrò? Ọlọ́nà ló kúrò àrí.
Bẹ́ẹ̀ni.
Ṣé kí ní ìdẹ́ wà recorded? Okay, we can wà recorded into the cloud. Okay. So, for the second part, báwo ló ṣe type kìíní? Okay, 1 point. Okay, mo ṣe mo ti rí 3 points tẹ́lẹ̀ ní ilé ìdẹ̀wà jẹ́ 1.3. So for this one now, let xn be that. So this is what I hope that achievement here is a strong convergence. Look at it here. Eléyìí, no, this is not equation. This is supposed to be equal to inclusion equal to the equation where u equals this guy. So this is not supposed to be inclusion. Okay, so from lemma 4.5, how? Where is from lemma 4.5? This is 1.1, there's no 4.5. From lemma 4.5, we have the inequality. This inequality is not anywhere. Cn plus 1. Because inequality, even from, okay, yeah, only 1.2. No, it's not.
No.
You can say 1.2 now. 1.2 only T. What is this T?
Tí yẹn wà questionable. Is it tau náà fẹ́ kọ àbí ò? Ibo náà ti rí tau gan?
Ẹsẹ̀ pé kò lè yé mi gangan. Tí mo ń sọ pé káwọn tó kọ ní kan ṣe nìyẹn. Even this one here, I don't know what they've done here. Applying the same band again.
Doctor.
Yes?
Doctor. Ẹ jẹ́ kí madam ó ṣe èyí báwọn náà wà ń bẹ̀ wọ́n yọ ṣe ni. Let her try it. Let her explain.
Yes, orúkọ méjìlá wọn yín pẹ̀lú.
Orúkọ méjìlá rí ń bẹ̀ náà madam ẹ wọ́n dì náà wọ́n ń sin ó yá iná ẹ̀gbá ẹ explain fún wa. Yes.
All right, sir.
I thought I like that. Ó yá mo like encourage yín jà ó yá explain fún wa.
Bóyá kí n gbé láti ìbẹ̀rẹ̀.
Ẹ gbé láti fẹ̀rẹ̀ 1.2. Ṣé kí n máa bá scroll àbí?
1.2.
But nǹkan tá a sún bíbá ẹ agree pẹ̀lú wa pé kò ṣe méjì ṣá pé ẹyọ kan péré lè prove.
Bẹ́ẹ̀ni, sir.
Okay, so let's go to fẹ̀rẹ̀ 1.2.
Only 6 point lásán wọ́n prove wọn ò prove.
Only 6 points nìkan no show, yeah. And this should be Zn nìkan.
Okay.
Ìbéèrè wa ń sìn ní pé ìbílẹ̀ ti rí tí ẹni yìí àwọn nǹkan tó tí ẹni ẹwú tó mú oyún ní nǹkan tẹ band. So this is what you have said here, applying the same band again.
It should be an error, typographical error, sure.
Okay, so if it is, then what should be there? Kí ni kò bá wà mẹ́? Because wọ́n pé typographical error mú pé nǹkan yẹn nǹkan tí èèyàn type ọ̀tọ̀ ní nǹkan tí èèyàn intend, àbí? Is that correct? Yeah. One minus psi n. So this is so just as good as saying psi n. Because 1 minus about bracket this guy and column will be. So something is missing as well there. I'm not quite along with Dr. Ogunsola. I don't know where I have maybe to my place where I'm going to download them. He left his save no. I don't go online assignment. Not enough is
Yes, it's online assignment.
Okay, no. Online assignment. So to don't call it 8.
No, online assignment, yes. Online assignment. Online assignment. They are light. Okay. No. But the recent ones, now maybe more send.
Okay. Check, it send me recently.
As in, the most of the made the send the buy.
Okay.
You send
look at what we're saying here. And we'll keep here. If you want some copy got to missing B, this is 1 minus rho. 1 minus pi n into 1 minus rho. And if we compare with this, which is the same thing here, but about loss in 1.2 in contact combination does not have that. Like this is just saying phi n. Because if you open this bracket, this is you're just going to get half phi n b back. So which is not what we're expecting. So 4.5 lemma 4.5 lele. Oh, this is the lemma 4.5. Actually, from lemma 4.5. But this conclusion is wrong because this is lemma 4.5. Look at the conclusion of lemma 4.5. So using the quasi inequality. Aha, so apara DBT look at this definition of M3. The definition of M3 says is the supremum of xn minus p, this guy,
And
this guy. Yeah, this one and this one. So the supremum of this guy and this guy. So in M3. So this thing will now be correct like this because this M3 does not include this guy. Let's get right. The M3 does not include it. So this will now be correct.
mo dẹ̀ observe nǹkan kan
Okay.
níbi tí àwọn Dr. Gafari yẹn wọ́n ní outside the bracket ní ìmọ̀ ilé tó ń bọ̀ láti ilẹ̀ but outside the bracket wọ́n square viper n ni wọ́n so bóyá viper n tá a rò bóyá kó wà ní ìbóyá ọ̀nà ti extract síta.
Níbẹ̀ yẹn sà
kò ní square.
kíní wà bẹ́ẹ̀.
ẹ máa ṣó lọ ní.
Ìbẹ̀rẹ̀ ìbẹ̀lẹ̀ àtẹlẹ́ ní méjèèjì ni àìsàn square.
Tí Dr. Busola àwọn ẹ̀ṣẹ̀ gbé síbẹ̀.
Ibi láti apply lọ́wọ́ sà okay. Yeah.
No, èmi nìyẹn position mi nìyẹn.
Okay.
Alójú ti kúrò mẹ́wàá ẹ̀sìn. Dr. Gafar gan sí mẹ́wàá. He's been locked out. Okay, so probably this is what we're going to use to correct it. So Elaine, so similarly again, just like I said the other time, Elaine, no, just go straight to this guy. That's all. Elaine, so I don't think we faulted anything here. So báwo la ká ṣe pín ara wa ń bẹ̀ báyìí sí? Like ẹyọ kan lélẹ́yìí. This is one, okay. The other one, what will have, okay, algorithm mention one be. Have to compare. Now look at the algorithm here. Algorithm one be right. Okay. Algorithm here. That should be the. Okay, I'm update the column. In with algorithm delay. Now let's go and look at it. First, so we're back on read to tell you to check in which should have been the best way to explain this to you. But I try not to see back on. Now, if you look at this thing that you're seeing here, step alakoko, this step here, W key. Just strip everything here in your mind and strip off. This guy, strip one off. Just look at it as if you're saying SK plus theta k into SK minus 1 minus SK. I think it was very clear.
Okay.
Check it, man. Just strip off this gradient of F star, gradient of F, strip gradient of F here, strip gradient of F here. So what you're going to have is just going to be SK plus theta k into SK minus 1 minus SK. So everyone have it?
Yes. That inertial step now.
So which will be the inertia, yeah. So this guy, this WK, there's no difference between it and this WK here. The only difference now, if you observe it clearly, is that this xn minus 1 will go 1b.
Then.
Only reason because of the space that is sharing. And that was the only way we could have done it then. That was the only way we could have done it then. That's quite a shit. This is not the normal inertia. I have to change the momentum. Because momentum is what do you call momentum? Momentum is a vector quantity, have it?
Yes.
And vector quantity is a quantity with magnitude is measured in magnitude and direction. Is that not?
Yes, that's right.
So which means the direction of this WK and the direction of this WK here, they're opposite. They might be opposite. Because this is what we call momentum. We call this momentum. So this guy here, only imagine Google WK, but this guy, theta k into this guy and this guy at Italy, they're in different directions, in the same direction because minus of that, so clear.
Yes, minus of that. That's what I'm saying.
So, but that aside, n tí mo fẹ́ kẹ̀kan rí bẹ́ẹ̀ ni pé it is the same thing. Tẹ́ bá ti yọ kíní kúrò ńbẹ̀. So now, if you look at this stage now, this step, yki equals pi ci, strip this guy off again. Strip this guy off again. You are going to get this thing. We are going to get this one. If you strip those things off, this guy, just change this pi c into pc. Okay, pc, the one billion. So just change this pi ci here to pc. Boya, Emma Binu, Eliko, you can write this. Be Michelle Sonia, so that Emma feel compare, I feel reload or continue. So write this and strip them off of those things. Koje na ẹ jẹ́ ká rearrange eléyìí kó má jẹ́ sk minus 1 first, kó jẹ́ sk minus. A fẹ́ fi compare ta ní tẹ́lẹ̀. Tí mo bá ti get eléyìí tí ò ń ṣe tí kò kí ń ṣe finite family yẹn, máa upload ẹ̀. Ilé extension eléyìí tí mo ní kí Dr. Gafar bá mi download yẹn ilé I extend it from Hilbert space to Banach space now. An extension from Hilbert to Banach. Mi ò mọ nǹkan tó ṣe gèrè sí o, kò yẹ fóònù ẹ̀ wò. Ẹ kó ti send ẹ̀ sí mi.
I need Dr. Gafar them. I'm going to download most of it.
You know, VPN school me too, sister. Hello, Dr. Grace. Good afternoon, it's fine. How is everything there? I sent you something that you should have download. I have not received it. Check, you should check, please check. Bàbá rí yẹn kò ní need pé ká ṣẹ̀ṣẹ̀ máa call I would love to display it immediately. But share ti kọ́kọ́ kọ first line here.
Yes.
Okay. So if you check that now, it's the same thing as this line here. Abi?
Yes.
I compare and contact pẹ̀lú kíni difference. What are those differences that you see?
The WK that call Abi.
Dr. Ogoshola you lost okay o.
Ṣé ń gbọ́ mi sí mi ò mọ tó ṣe network.
Mo gbọ́ yín, try láti gbọ́ yín báyìí.
Ẹ gbọ́ mi.
Mo gbọ́ yín báyìí, mo gbọ́ yín.
Mo ní ṣe bí first inertia point lẹ́ni ká kọ which I have written.
Yeah, ká fi compare ilé.
Okay. The only kò sí difference na yàtọ̀ sáwọn.
There is a difference.
Apart from the direction, that's the only difference there.
Mo ní kẹ́ kọ correct direction, mo ní kẹ́ kọ.
Okay, ká kọ ní correct direction.
Correct direction.
Ó máa jẹ́ SK minus SK minus 1.
Plus theta k, SK minus N minus SK.
Yes. Need correct direction. Ó máa
jẹ́ SK minus theta k.
No. Okay,
SK minus SK minus 1.
No. Correct one. Need the correct direction.
Tó bá kọ ní SK minus 1, sir.
Ní correct direction. Tó bá pé minus lè fẹ́ fi síbí.
Which is always SK minus SK minus 1.
Tẹ́ bá fi minus síbí báyìí. Àti ní correct direction yẹn. Or kí lè jẹ́ plus.
Okay, yẹn máa jẹ́ plus.
Tàrí yẹn náà. That's all. No, kò ní jẹ́ plus. Tẹ́ bá fẹ́ kọ ní correct direction. Ẹ gbọ́ mi, tẹ́ bá fẹ́ kọ ní correct direction. Tí lè bá jẹ́ plus. Tẹ́ bá fẹ́ lè bá fi jẹ́ plus. Ẹ kàn change inú bí láìsàn ni kò sí nǹkan tó lè jẹ́ kí minus 1. Correct direction yẹn, which is this guy. Which is this. That theta n xn minus xn minus 1. But tó yẹ pé plus lẹ́fẹ̀ẹ́ tó yẹ pé bí ẹ fẹ́ change eléyìí sí minus ni. Tẹ́ bá ti change eléyìí sí minus, ó ti di wà ní correct direction straight again. Because if you put minus here, minus times minus dey apart plus.
Emma Binu, the last one, which is SK yẹn, that is the last one be ṣé kò ní affect tá a bá fi minus sí
tá bá fi
ibi
minus sí bí
ẹlẹ́ẹ̀kejì ṣé kò ní affect
tá bá fi minus sí
ṣé
bí
kò
àbí
ní bẹ́ẹ̀ ni sà ṣé
tá
kò
a
ní
wá change
affect
eléyìí kò affect ẹ̀ náà tá bá fi minus sí bí minus times minus kí ló máa fún wa
fún 1 plus.
which is what you're supposed to have in the first place. Xn must carry plus only. Plus times plus
All right,
Xn
sir.
must be plus.
All right, sir.
So if you change this to minus and you change this to plus, ẹ tún ti nǹkan kan náà ló ṣì wà. Bó ṣe wà tẹ́lẹ̀ náà ló wà, kò sí nǹkan tó yàtọ̀. So if you change this to minus
Doctor,
one. Yes, sir.
doctor, I need clarification. I don't get it well. Let
Okay.
let me tell you what I wrote here.
Okay.
WK is equals to SK plus theta K
Yes.
into SK minus 1. Is that
And
correct?
to correct lẹ́kọ̀ọ́ yẹn. Nǹkan tó correct lẹ́kọ̀ọ́
Okay.
yẹn. Yeah,
Okay.
that is what is correct. It should be
Okay.
xk into theta k as
Okay.
xk plus theta k into sk minus sk
SK.
minus 1.
Okay. Okay.
Mo wá sọ pé difference wà nínú yẹn àti
Okay.
eléyìí ilẹ̀ wa àti ìmọ̀ difference yẹn àgọ́ difference ló wá wà ń bẹ̀. Mo kàn fẹ́ kẹ́ wà meticulous ni. Difference wà ń bẹ̀ ni pé bọ́n ṣe kọ sequence wọ́n ṣọ̀tọ̀ọ̀tọ̀ wn yìí ìsàlẹ̀ ni n wà.
Oh God! Ọmọ yóò ta àwọn pé bẹ́ẹ̀ mí nìyẹn. Oh, in fact, you are too diplomatic, Ọ̀gá.
Èmi ò kàn tẹ bọ́dà àti kọ́ sókè ilẹ̀ lèmi kọ́
Honestly,
tẹ̀.
mi ò tiẹ̀ ró lọ bẹ̀ẹ́ rárá.
Kò fẹ́ kẹ́ wà meticulous ni.
Does it have any reason tàbí kọ́ bẹ́ẹ̀ àbí it's just the same?
No,
It's
just
just
to ẹ̀mí ò pé conventionally bẹ́ẹ̀ ni ó bó ṣe wẹ́ nìyẹn bẹ́ẹ̀ mi ṣe ro.
Different tá a ṣe máa ń ṣe báyìí ni pé kó má di pé ó máa jọra wọn jù.
Okay.
Understand? Lẹ́yìn ọ̀kan bá ti ṣe nísàlẹ̀ èèyàn lè ṣe tìgbé lókè.
Okay.
So sequence náà sequence jẹ́ but kó má bàa jọra wọn. La ṣe máa ń ṣe báyìí. Tá a bá download the other one ṣé pé wọ́n ti send ìyẹn sí mi sí ni ẹ máa rí pé there is no difference. The only difference tí a máa rí nínú ìyẹn tí mo fẹ́ show yín sí àtẹlẹ́ yìí just this tí mo ní kẹ́ máa kó lára wọn ẹ̀. That's the only difference ẹ máa rí. Gbogbo kìíní tí mo ní kẹ́ kó lára wọn ẹ̀ nìkan ẹ máa rí difference. Now let's write this next one. We just got the next one. So in the next one, that fẹ́ kàn sí ẹ change eléyìí kúrò ní pi c kẹsàn di pc.
Okay.
Kò máa jẹ́ pc raised to power I báyìí. Ẹ̀kọ́ yẹn náà. Then ẹ yọ strip off those gradients.
Okay.
We just got one tẹ kó ká wá fi compare nta àti ní tẹ́lẹ̀. Just change the pi c kó di pc raised to power I bó ṣe wọ̀nyẹn. Pi yẹn nìkan lè kàn fẹ́ change so the p.
Okay. I think I'm done.
Wọ́n á jẹ́ pci bracket yóò lè kúrò bẹ́ẹ̀.
Into bracket
wk
minus alpha k
fi
wk.
Exactly. So that is correct. Which is, if you look at the only difference between that and this now is the eyes.
Yes.
The only difference between what they call silencing and the is the eyes. Really,
Yes, yes.
what in the eye lori, what in the eye lori. So that's the only difference. Abi?
Yeah.
So then it will include this guy that the eye is going from 1 to n. So we can take any line of WK. I need YK1, YK2, YK3, YK4, YK5 up until what? YKN. You can take any for computing here. Up until YKN. Then the next one, ZKI. Is there any difference between this ZKI and the former ZK? Is there any difference? No difference. The same thing. The vowel PTN into this guy. Let's go to it. We know TKI into that thing. The vowel can you come better so later the can you the same thing now like get the lane no you need we know like way. So anything you can try that to read.
PTI WK minus.
So another difference tí mi ò fi kún ni pé ìgbà tá a lo sequence yẹn any la lo bẹ́ẹ̀ àbí kelele no kelele so that's another thing. Ara àwọn little difference tẹ́ máa change bẹ́ẹ̀ nìyẹn so that kò ní jọra wọn pẹ̀lú ibi tẹ́ tí ń bọ̀.
Doctor sir.
Yes, sir.
Why ṣé I ní YK yẹn ṣé ká kọ I yẹn tó bá jẹ́ subscript kó wà lẹ́gbẹ̀ẹ́ ibi tó instead tó wà lókè yẹn kó wà lẹ́gbẹ̀ẹ́ ìsàlẹ̀ ṣé ẹ̀yìn àbí ká fi I sókè tó
Another way to
títí
feel
wà.
if you eye sókè, if you any exercise, any command, you know. Ṣé I wà lókè kí ẹnu wà sálẹ̀. So it depends on you. Bó wá ṣe wù ní ṣe lè kọ́.
Okay. Should we call it? Should we tell you what we did?
Okay, so kí lẹ ní bí?
I think here I have hello sir.
Yes, I'm with you.
PTI
Okay.
into bracket WK minus alpha K FI YKI.
Okay, but pé kí n bí báyìí o.
I know.
Níbi tí-
ZKI is equal to PTKI
Okay, into WK,
into bracket WK minus alpha K
alpha K, FI, YKI.
YKI.
So if you compare with this, the only difference is the inclusion of I now. I'll be very
Yes. Then.
So that's the only difference.
then.
So then, the half space is the same thing. You see the half space now. No. The definition is the same thing. Just that elite include kinio, which include I. That's all. Ṣé nǹkan try láti get nǹkan bẹ́ẹ̀. But
Yes.
it's almost the same thing náà nìkan tó wà nù paper elite tó ń publish yìí o.
Yes.
Àti tá à ń ṣe ń bí.
Of course.
Now the difference is that this one is now finite family. Finite family eléyìí rí pé I equals 1 to what? To n. Eléyìí sì kò stop sí bí ó run up until what? Until n. YK1, YK2, YK3, YK4, YK5, YK6. Tàbá ní pé ká kọ gbogbo kíní sínú bí báyìí, paper ò ní gbà o. So that's what you're just saying. I running from 1 to n. So it's a finite family. So now, this is just for single operator A. There are n operators for this one. And for each one, I, F1, oh my God, from F1, F2, F3, up until what? Fn.
Fn, yes.
Look at the number of operators. So that's the difference. This one is just one A. F, this is just one F. But here, there is a finite family of Fs. And there's a finite family of Cs as well. From projection, from set, feasible set. Because actually, I, Ci. For each Y key, there is a Ci. So the same thing here. For each Z key, there is a TKI. Like that to run. And this is the definition of the TKI. Now, this part, in turn won't be VKE. VK way is the same thing. If you look at it clearly, this is a man iteration. Well, only man clear man iteration way, finite family, 3.4 year. Man iteration here, which is exactly the same thing that you have here. Tag with the TN. It is exactly this thing that you have here. And to one square bracket here, 1 minus beta n zn plus chemical is the same thing. Eléyìí la fi collect gbogbo n tó ń run yẹn. La fi collect gbogbo n tó ń run. Kìíní la fi collect wọn. Ẹ máa rí pé this is delta K0 WK plus it's not delta I going from what? 1 to n. A ti collect gbogbo ZK yìí pátápátá sínú summation yìí. One way that fi máa ń ṣe tá a bá ní láti dín pẹ̀lú final family. Another way a máa ń lo parallel method. Parallel method ni ó dà pé ó wà nínú paper tí mo ní kí wọ́n máa mi download yẹn. Parallel method ní títẹ̀ ẹ máa select maximum of all these numbers. Ẹ pé eléyìí máa generate YK yìí ó pé from 1 to n in YK yẹn. Àbí? Same as ZK. So method yẹn a máa perform one maximal optimization problem lórí ẹ̀ láti determine èwo la máa lò la máa choose bí the same thing bí báyìí a máa choose ẹyọ kan bí náà so ilé ìta bá lò bí ló máa represent gbogbo YK tó wọn mistake ta fi máa lo gbogbo YK tó yẹ pé each one YK náà ilé ìta bá ti select as the distance ló máa lò bí báyìí then ibi báyìí náà same mistake ta fi máa lo ZKI nínú bí báyìí nílò summation yẹn mọ́ a kàn máa pick maximum yẹn to satisfy that thing maximum yẹn la máa lò bí directly bí bá a ṣe ní zkb bá a ṣe ní znb zn náà la máa lò mẹ́ẹ̀ but that zn will be maximum of all these ones but another method tá a tún lè lò is just to add this thing add all these zkis together tá a bá ti add ẹ̀ a máa get ẹyọ kan báyìí instead of máa ṣe lẹ́yọ kọ̀ọ̀kan fún vk ẹ bá rí pé vk yìí kò run títí ẹ̀ it's just vk. If you look at the VK, ẹ máa pé òun run kò sí IMEN títí ẹ̀ just VK because it is just this àti ro gbogbo ZK yẹn papọ̀ ó máa fún wa ní nǹkan ẹyọ kan péré because this is the summation of it so it just give us one so we don't need to run this but eléyìí run because each time bí báyìí ó run that's why this one is ZKI so but eléyìí kò run mọ́ then after that where ṣètìrì gbogbo kìíní ẹ̀ ó add up to kìíní o ó add up to 1 all these datas to multiply each one they add up to what they add up to 1 so their values is 0 1 and they add up to 1 just like beta n plus 1 minus beta n kilo number from 1 yeah so this is a converse combination of wk and all the what zkis. VK is a converse combination of what? WK and ZKIs. So it's just like Kasokwe N is equal to 3, for instance. N by 3. This will just be VK equals delta K naught WK plus delta K1, ZK1, delta K2, ZK2, delta K3, ZK3. This is genuine. So explanation be clear?
Yeah.
So finite family. Yeah. So I put K is equal to 1, for instance, N is equal to 1. When N is 1, when this N is 1, we return back to this algorithm. Remember D, crash algorithm. The moment N is 1, we come back, it becomes this algorithm that way. The algorithm delay. J1, then this algorithm becomes this one. Sorry. Then we will calculate SK plus 1. SK plus 1 is also, now here, happen lele. But kí la lò ń bí viscosity la lò ń bí. Nítorí ṣe jẹ́ happen ni pé a kì í lo viscosity nínú space yìí, nínú reflexive Banach space. We only use happen. Happen nìkan la máa ń lò ń bí. But since we kò ṣe space la fẹ́ ṣe, Hilbert ni, so we can use our happen iteration as we have it here. So àwọn èèyàn group kan máa stick pẹ̀lú this algorithm, another group will stick with the one that is finite family. Don't make clear, so. So, Emma Binu, I'm going to Dr. Ogosholama will be grouped to match finite family. So, lẹ́yìn yẹn ni àwọn bẹ́ẹ̀ ṣe fẹ́ ká pínra wa sí bọ̀dá àwọn èèyàn wọ̀n mẹ́ta wọn. So that's going to be a disadvantage now because I can fall in olórí. Unless you want me to do the pé fúnra mi látọ̀dọ̀ mi bí nìkan ló kù.
You can share it with your teacher. Give us assignment. Let's
Okay. But explanation me so far, so clear, sir.
Yes, so
In
clear.
case torí àwọn tó fẹ́ ṣe finite family yẹn. Mo ní pé in case torí àwọn tó fẹ́ ṣe finite family yẹn is the explanation clear enough.
It's clear to me.
But first, the background knowledge, we can't okay, there's no difference between nǹkan tó wà bẹ́ẹ̀ àti nǹkan tó lè. Most things, nǹkan tó wà bẹ́ẹ̀, the only difference will just be ẹ kàn máa rí pé gbogbo the same thing tẹ́ ṣe ń bì náà lẹ máa ṣe nù yẹn náà, ní tẹ́ ṣe ń bì lẹ máa ṣe ń bì yẹn. The only difference is just ibi tẹ́lẹ̀ kan ti ń jẹ́ WN lásán, irú eléyìí tó jẹ́ ZNI lásán, ó máa ní I, ó máa ní I, ó máa ní I. It's difference nínú computation. Just get mine.
All right.
Kò ní sí difference tó, the difference won't be that notable. It won't. Ẹ kàn máa rí pé okay, change of WN lásán lélẹ̀ bóyá kó jẹ́ WN I ló yẹ kí nǹkan combine, that would be the difference. If you look at the way we have worked it out, the same thing. Let's look at one of the lemmas. Kí n lọ fi hàn pé okay o, this is the analog of this lemma. Look at this lemma. Our lemma is in WZ kìíní kan, WZKI, which is less than or equal to this guy. And with 3.10 yìí nìsín. conclusion kìíní yẹn o ní pẹ̀lú P and ZKI nǹkan tí tẹ bá factorize àbí tẹ bá estimate P ZKI DF yìí ẹ pè ní norm lọ́dọ̀ títí òun ni norm nínú space àtìmọ̀ so this thing then with DF P ZKI is just the same thing as saying the norm square of P minus ZKI, that's all. Norm square of P minus ZKI. This is the norm square of P minus WKI. This is the norm square of YKI minus WK. This is the norm square of ZKI minus YKI. DF here is norm square in a Hilbert space. This DF will be norm square. Now let's look at this P minus ZKI. And just compare, you see that you are going to have the same thing. In between to expand ZKI minus P. Only you can see. The only thing is just this has been factorized. And so we get 3 times now won't be Abi 1, 2, 3.
Yes.
Now let's go to 3.10 again. 3.10. Only. So if I factorize, I can factor out kini méjèèjì yìí ń bí. Instead of my color kan, ele multiply by ele minus ele times ele àti factor out méjèèjì yìí. Bí pé kẹ́yìn náà factor out.
Ọlọ́run ló mọ tó ń ṣe kúsọ̀ yẹn. Ọ̀tọ̀ níbi tí mò ń rí, ibi tẹ́ bá gbé kútọ̀ sí, ọ̀tọ̀ níbi tí mo ti ń sọ̀rọ̀.
3.10 rí náà. Ṣé ń rí 3.10?
Tọ̀dọ̀ mi lẹ́sí yìí mi ò rí ti bí yẹn mọ́. Mo ṣe rí sí mi ò lè parọ́. Mo ṣe rí 3.10 sí ní ṣe agbárí mo fi ń gbé gbogbo ẹ̀ láti ìbàlẹ̀ ní sọ.
Okay, so 3.10 nìyẹn. Náà ẹ wo 3.10 yẹn.
Ọ̀gá ẹjọ́ sà ṣebí kínní la factorize jáde kúrò ń bẹ̀ 1 minus mu alpha k.
Alpha 2 plus sigma alpha 2 plus 1. We'll have factor out.
Yes, sir.
So only tẹ́ bá wo 3.10 yẹn jẹ́ ká fi compare títí wọn yẹn again. Mi ò wá mọ kíní òun wá.
In fact, ìdí mò ń pass through bí kò yé mi rárá.
Òun rè
ibi tí kúsọ̀ bá wà ọ̀tọ̀ níbi tí
system yìí ló slow. So
mi ò tún rí tẹ́lẹ̀ ọ̀dọ̀ mi tẹ́ ṣí ń sìn báyìí.
Ó ti yé mi sà.
Mo tún ti rí sìn.
Ṣé rí pé the same thing?
Okay, bẹ́ẹ̀ ni sà.
The only difference being that height one being yẹn kò sí IMB. Tó ẹ ń pé o ní Hilbert space directly ní DF kó má bàa confuse ẹ̀ bá rí pé norm square ni but ẹ ti understand pé DF tẹ̀ rí ń bẹ̀ yẹn o ní norm square ilé.
Bẹ́ẹ̀ni.
So the same thing but now kí wá ní nǹkan tá a wá fẹ́ ṣe ń bẹ̀ sí ni pé tẹ bá wò yẹn ẹ máa rí pé inertia kan péré ló wà ń bẹ̀. Let's go back to that thing.
Tó ní WK.
Inertia kan onìkan ló wà ń bẹ̀ ẹ̀yọ̀kan ìpínlẹ̀ ló wà ń bẹ̀. So a ti fẹ́ fi mí kún báyìí fún àwa. You understand? So the UK máa ti wọ́n bí nsìn.
Okay.
Eléyìí fáwọn tó fẹ́ ṣe final family ni o.
Okay, sir.
UK máa ti kún báyẹn. UK máa ti kún. And then around fún tẹ máa rí bí pépà ilé ni pé kò sí tí yẹn bí irú pé ibi tó yẹ kí tí wà ń bí bá a nílò tí mọ́ because okay ká pè ní U kí wọ́n pa ti fi tí ṣe house space. A lè lò ní U.
A ti fẹ́ lo U náà.
U la lò níbi títí bá a ṣe define it yes pé instead yẹn pé tí làwọn òbí kò dẹ̀ sí tí kankan bí eléyìí ni mo sọ pé let's make this one U now so máa jẹ́ U. But ẹni tó bá fẹ́ ní paper yìí sìn ẹni lè rí eléyìí lò dáadáa because there is no fixed point in this one. So you understand my kò sí fixed point nínú eléyìí rárá it's just division inequality straight away. But now, after key fixed point 1, that is, we want to include U here. And that U will have the same definition as the U. Final family. That is, it has to be demimetric. So, Manila has the same paper, but I want to demimetric. So, just final family, see 1 year. So, find out final family. So, me clear?
All right. Hello, doctor.
Yes, sir. So, question
you said something about viscosity.
Yeah.
This particular one, step 4, is not a viscosity.
No, what is up with step 4? Malnutrition here.
So that is not
xn plus 1 kò ní xn plus 1 only ẹ jẹ́ kí n gbé padà lọ sí xn plus 1. xn plus 1 so xn plus 1 here is happen here.
Okay.
kí ló fẹ́ ṣe jẹ́ happen ni pé a kì í lo happen nìkan náà ní strong convergence method tá a máa ń lò nínú reflexive Banach space yàtọ̀ sí pé wọ́n bá ń ṣe àwọn condition but nínú method méjèèjì happen àti viscosity happen nìkan la máa ń lò nínú reflexive Banach space àti two uniformly convex lẹ́sẹ̀ iṣẹ́ tí tá à ń ṣe lẹ́yìn yẹn. A kì í lo viscosity náà space yẹn. But nínú feedback we can use happen yes happen nìyẹn máa pẹ́ x naught ló ti bẹ̀rẹ̀ nígbà.
ní 3.5 happen ni.
Yeah, happen ní 3.5 yìí. Eléyìí ẹ má rò pé bóyá ó ní f tó wà bí is the gradient of f. Gradient of f lélẹ̀ òkun ṣe ṣe pé normal viscosity ó yẹ kó jẹ́ f of something.
Yes.
Àwọn ò ní kí lórúkọ kò ní ní gradient lẹ́yìn o. What is the algorithm? Don't worry. Ẹ rí pé phi n of f of un. So gradient of f yẹn ní meaning nínú space yẹn ó wà lára definition Bregman gangan fún ara rẹ̀. So if you go back to that thing, you see the definition of Bregman that it comes with gradient.
Okay.
Definition of Bregman rèé df ṣẹtiri gradient of f one. So it is because of the definition. So that thing that you're seeing is nothing but happen iteration. Happen lele. And VK is man. VK is man. Just like bó ṣe jẹ́ man ní títí inú eléyìí tí wọ́n ṣe final family tá ìfi kọ́kọ́ ṣe yẹn. So níbi tá a máa ṣe sínú tí máa fi mú group yẹn jáde. So but ẹ bá ní question ẹ lè béèrè. So what I'm going to do now, I'm going to put this one. Eléyìí tẹ́yìn ti ṣe yẹn tí Dr. Ogunṣọlá máa gbé sí the group again fún kí every other person to study it. So if there's anything that somebody wants to ask, a question that you want to ask, you can ask from there. So kí àwọn umu house àti abu house kan lọ ṣe correction tí wọn náà, they should use that as a means of doing the correction. So if there's anything from that you can ask. So clear, right?
Doctor, my question is this. So hello sir, hello.
Yeah, I'm with you.
So if I didn't get you wrong, sir, you now want to use two double inertial methods.
Yes.
For finite family, sir.
Exactly.
In the reflexive Banach space, Abi?
No. Hilbert space.
Hilbert space. Okay. All right.
Hilbert. Tabawa ti wa successful bí ibẹ̀ yẹn o, àwọn á lè padà sọ pé okay, now let's do Banach space. Once you are successful with that, when the flexible Banach space láti lè torí pé mi ò rí ìyẹn download ló yẹ kí n lo paper ilé. You understand? Kí n fi explain. Ṣé pé paper ti mi yẹn directly mo rí ìyẹn is Hilbert space nìyẹn. Hilbert ni, let me go there. And so we see it from...
Can I make a submission?
Okay.
Currently, I'm working on something very close to that.
Okay.
Maybe I should share it with you.
Working on what?
Yes, from our assignment, Mo algorithm where I used to
inertia.
Then at the same time, we solve problems equilibrium at equilibrium at fixed point.
Okay, yeah, that won't be a problem.
Okay. But
if you want to share, you can share. You can share.
Family, not a finite family.
More. So you can share. Let's see.
Can I
you can share. Let's see the method. Yeah.
All right, sir. Let me.
Dr. Alukotilo.
I just got study by me.
Once
it's not there. All right, sir.
You can share now. Let me see.
Please, how do I get off? I got from here. Mobile laptop. Me get kini mo wo video wa mo wo nsin báwo ni ma bọ́ síbẹ̀ yẹn padà sá.
Ẹ kàn lọ síbi share.
Without leaving the front.
Ẹ kàn lọ síbi share.
Click on share. Yes. Okay. All right. Oh, thank you. Okay. My appliance.
but tí open paper tẹ fẹ́ kárí o ọ̀tọ̀ ní nǹkan tá à ń rí o.
ó ń ṣí ìjẹ̀fẹ̀ sí ibi tí ẹ wà níta. Internet is unstable. I don't know how to get stable. System to them, take time to see me. I'm sorry. I'm sorry, SARS. SARS are mad, please.
I'm mad.
Otin boot, machine, please.
Sáwọn Dr. Gafar lọ bí àkíkọ́ ni.
Sá, a wà pẹ̀lú yín o. Èmi wà pẹ̀lú yín.
Oníṣẹ́ Dr. Gafar lọ bí ọlọ́mọ ni.
Wọ́n lọ bí ọlọ́mọ o.
Ọlọ́run láti fún wa sí.
Àwọn lálọ́ọ̀dù ló ránṣẹ́ pè wọ́n.
Okay.
Yes, sir.
Àbí àwọn fellow landlord. What do you mean àwọn landlord? What's it called? Fellow landlord. That's how to put it.
Àwọn fellow landlord.
Àkálẹ̀ ìṣirò ti bẹ̀rẹ̀ ni.
Kí lẹ sọ?
Rárá sá. Àná ni wọ́n ṣe wọ́n ti ṣe lọ.
Okay.
Digital analog ni system Dr. Goshola.
First generation náà ṣe ń lò.
Ẹ wo ṣe ló gbé test studio ẹ síwájú. Ọlọ́run ṣáà. Dem no disappoint me working ni.
System náà máa ń ṣe bẹ́ẹ̀.
Ẹ wo iṣẹ́ ló gbé test studio síwájú ló wá ń dàn búùtù ló búùtù.
Olóòdù ó sì ń lò dárí.
Adánidó lọ́kọ̀tà àkọọ́lẹ̀ wo lélẹ̀.
Olóòdù.
Ẹ ò kẹ́ ń rí sà.
À ń rí. Ẹ mọ̀ wọ̀ yóò ṣe sùúrù ló gbà.
Ó máa ṣí ìyá wọn.
Ẹ má bínú ẹ jọ̀ọ́, ẹ má bínú o.
Àjàgbé ni ẹlẹ́dẹ̀ rẹ̀ fẹ́ wọ̀ lọ Ọ̀yọ́ ni.
Ẹ yóò débẹ̀ kẹ̀lẹ̀kẹ̀lẹ̀ yóò débẹ̀.
Iṣẹ́ ló máa ìbàdí bá ní ìdí urgently gan ló máa ṣe yánmayàmá òṣì.
This open load, that's the most important thing.
Network yìí ló ó kọ́ tèmi náà fúngbà díẹ̀. Ṣé kí la bá débi bí?
Wọ́n sọ wípé Dr. Ogúnṣọlá sọ pé àwọn ti kọ́ the same method ilé ìta fẹ́ lò fún VIP yẹn. Àwọn kọ́ fún EP, wọ́n kọ́ fún equilibrium problems. Àwa fẹ́ wò ó.
Àti ìparí.
Wọ́n máa try.
Wọ́n ní pé ká wo method yẹn àwọn ti kọ́ fún equilibrium problems. Ṣé òpá sọ ń gbà yẹn náà pé a lè lo àwọn method yẹn fún as many optimization problems.
Yes, yes.
Bóyá kẹ́ ẹ ràn wá lọ́wọ́ kẹ́ ẹ send ẹ̀ sí wa. Ó dà ń pé kìíní yìí kò fẹ́ ká rí òun.
Bóyá kẹ́ ẹ send the source code ẹ̀ sí.
Inú group yẹn kàn send ẹ̀ sí wa ká wò ń bẹ̀. So a lè fi ṣe discussion ní next time. But I'm a group around just like I've said, so we can start working on it. So clear, man.
So
essentially, we are going to take it from there. So and if there's a comment that we need to pass, anybody can send us.
Send us a group,
yeah, I send us.
Okay. I'll send it to
you.
I'll send it to you and send it to the group.
Yeah, send the company comments, so I'll pass on it. But Kamagba will share that is our main work. So I'm going to send the group. Then I'm going to do that. So
okay.
Sir, before you leave, sir.
Okay.
Hello, sir.
Well, with you.
Hello, sir.
How are you?
Before you leave, the XM+1 here. Ṣé ń gbọ́? Kò ní jẹ́ viscosity mọ́, afẹ́ ló máa jẹ́ àbí.
Viscosity náà ni sísọ pé Hiba space láti fẹ́ ṣiṣẹ́.
Okay. Ká sọ di viscosity bó ṣe kó wà.
A máa yí change ẹ̀ nìyẹn.
Wọ́n wá máa change ẹ̀ nìyẹn.
Viscosity ló wà tẹ́lẹ̀. Viscosity lẹ lò nínú ti eléyìí tí ò ń ṣe finite family yẹn náà.
Oh, right. Okay.
Bẹ́ẹ̀ni.
Finiteness la fẹ́ introduce sí báyìí sí.
Exactly, that's the only thing. Àtàbà tún downgrade from viscosity go a downgrade ẹ̀ now.
Okay, sir.
Viscosity ló wà tẹ́lẹ̀, viscosity la lò tẹ́lẹ̀. So tàbá change ẹ̀ kúrò ní viscosity àti downgrade ẹ̀. A kàn fẹ́ kó jẹ́ finite family, that's all.
Then my own understanding is just like exactly what we did before. We transmit it to family. That's all.
Exactly. A fẹ́ kó jẹ́ finite family. Kó má jẹ́ straight up comparison. Yeah, that's what we want to do.
Okay.
Ìyẹn náà pè ní extension. So you have extended it from just solving one racial equality to solving a common solution. Common solution, right? Common solution to a finite family of variational inequality problems. Like I can display Ellie, stop sharing, Dr. Obushola. Let me try to share.
Then ọ̀gá ẹ má bínú fún question mi sà. Mo ní níbi tí oní finite family yẹn. Kíní ló wà níbẹ̀? Kíní lẹ sọ pé ó wà níbẹ̀? IPAN. Ṣàmánì láti change ẹ̀ sí viscosity.
IPAN ló wà nínú eléyìí. Reason tí IPAN ṣe wà níbẹ̀ ni pé a kì í lo viscosity nínú reflexive Banach space. Yeah.
Okay.
So kíní la lè lò ń bẹ̀. The only thing that lè lò ń bẹ̀.
Extension that can mention is we introduce finiteness. That's all.
That's all.
All right.
So what we have done before, we just want to introduce finiteness. That's all.
All right.
We are still working in Hilbert spaces.
Hilbert space yẹn náà lè ti fẹ́ sí gbogbo tẹ́ ṣe yẹn lásán. Ká sọ pé gbogbo nǹkan tẹ́ kàn fẹ́ máa ṣe mẹ́ ni pé kẹ́kàn máa fi I síbi tó yẹ kí I wà lórí ilé kí I wà lórí ilé. Lọ́tà fẹ́ ṣe mẹ́ ni pé.
But a máa kọ́ ní format tí yẹn fi kọ́ bí wọ́n ṣe ń fi gradient stuff yẹn sí a máa ṣe bẹ́ẹ̀.
Kò ní gradient
No.
inú Banach space láti máa lo gradient.
Dr. Aluko kò ní gradient ẹ̀kan nu rárá. Finiteness nìkan la fẹ́ fi sí. Àwọn highs yẹn la kàn fẹ́ add.
The only thing now, let me see. The only thing tó fi máa yàtọ̀ nsìn. Let me go back to that thing. Ní tó fi máa yàtọ̀ ńbẹ̀ ni pé ibi tí man nitration ti tàn yẹn.
Mi ò gbọ́ yín mọ́ o.
Man nitration ti bí yẹn títí inú eléyìí tí ó ṣe finite family yẹn kò ṣe bí man nitration ti tẹ̀ ṣe rí rè tí n ní títí ọ̀rẹ́ báyìí o ṣe rántí.
Your internet connection is unstable.
Ṣé ń gbọ́ báyìí?
Kí lẹ wí?
Ṣé ń pè tí n ní títí bẹ̀ yẹn eléyìí tí ó ṣe finite family yẹn 1 minus beta n something plus beta n kankan lòun jẹ́ ń títí tiẹ̀.
Yes.
Láì ta man iteration ti finite family yẹn bó ṣe máa rí leléyìí just remove the gradient kúrò níbẹ̀ fún bí finite family ti tẹ̀ ṣe máa rí rè ṣe ti get báyìí sìn bó ṣe máa rí bí tn tó jẹ́ bí tn lọ́ọ̀ yẹn tó máa rí bó ṣe máa rí rè.
So tí a ní tn níbi eléyìí níbi títa fẹ́ ṣe ń sìn nìyẹn mọ́.
Ó wà ń bẹ́ẹ̀ ó ní bóun ṣe rí rè instead tí ó fi jẹ́ jẹ́ kí n open kejì yẹn náà. Bí kìíní ìṣẹ̀lẹ̀ bọ́ sẹ́gbẹ̀ẹ́ ọ̀tọ̀ọ̀tọ̀ ṣe ti rí bó ṣe rí mi tí n lélẹ̀ ìsìn tí n ní 1 minus beta n zn plus uzn yìí n tó wà nínú square bracket yìí ó ní tn nínú ilé tí ó ṣe finite family. Yes. 1 minus beta n zn plus beta n uzn. Wọ́n ilé tó jẹ́ finite family tí mo sọ ń bẹ̀ sí ni pé bóun ṣe máa rí rè ó máa jẹ́ delta k naught wk plus delta ki uzki. Kí lẹ sọ?
Hello sir. Is it now a VK?
TN eléyìí. Oh, this is the new TN now. Eléyìí ló máa jẹ́ new TN.
TN á jẹ́ delta K naught WK plus delta KI UZKI.
Exactly.
Okay.
Nǹkan tó ṣẹlẹ̀ ni pé first náà ẹ kọ́kọ́ kọ algorithm yẹn jáde náà tí wàá ti kọ́kọ́ pín group yẹn ẹ kọ́kọ́ kọ algorithm yẹn so tí a bá ti wá kọ́ máa sọ pé ilé wrong ilé correct ṣe get why this is it's correct here now it's wrong here so let's see that way gbọ́n ẹ̀pẹ́ kan lọ́rùn to it so if you don't understand it the way I put it then mo máa rí nínú ọ̀tẹ̀ bá ṣe but this is the clear explanation that the Tn for that one tó jẹ́ 1 minus beta n zn plus uzn will not be that anymore it will be this mo dẹ̀ sọ reason tá a ṣe eléyìí fún wa. the reason why this part has to be like this, because you have to find a means of selecting one ZQ. Only optimization problem, that is select to maximum can be right. Or this summation method, or there's another method they call cyclic method. Cyclic method, no, cyclic method, not so finite family. I will have left you to go and read all this, but there is the time that must have okay, while not having solved finite family. So this is one method of solving one finite family. Problem to initiate with the finite family. Method called it. Another method is to use cyclic method or the parallel method. So here, this is the summation method that we've used here. So Tn, the one you know, you need to finite family that's what question. I replace Tn here. We're going to replace the Tn now by something like this. This is how it's going to be now. So it's clear. Hello?
We start with Amabere pẹ̀lú ti algorithm yẹn, so from there.
Okay. All right, sir. So just bye.
All right, thank you.
So I'm going to share the group, then so I'll learn more.
Ṣé tá a bá kọ algorithm yẹn tán, èèyàn lè forward ẹ̀ sí?
Yes,
no. So forward so that if I mistake, I'm going to group because I won't anything because it's like it's done. Abi?
Yes.
So the group so
numerical stuff.
Yeah, those are those things. The one man need to in paper format. Could you just analysis lesson? You have to do the whole things to make it a paper. Yes, that's the work there. But the analysis, which is the core thing, need to it's like be doctor or so our mistake correction for local that's all.
All right. Yeah.
Okay. Okay,
Okay,